Hi friends, welcome to SS Academy. Now today's topic is suitable rays for convex mirror. In the last class we have discussed about the suitable rays and the ray diagrams for concave mirror. Now we are discussing about the suitable rays for convex mirror. Here in the case of convex mirror, everything is same. The complete procedure for drawing a ray diagram is same, but here only three suitable rays are possible here in the case of convex mirror. So namely, the first one is parallel ray, and the second one is ray traveling in the direction of focal point, and the third one is the ray traveling in the direction of center of curvature. So these are the three rays which are also known as appropriate rays, which are also known as suitable rays for convex mirror. So here let us go for the first one, parallel ray. Parallel ray. So this is what convex mirror, this is non-reflecting surface, and this is what principal axis, this is called pole, this is center of curvature, the midpoint is known as focus. So we are taking the ray parallel to the principal axis. So I am drawing a ray which is parallel to principal axis. Got it? So we know that the ray parallel to the principal axis will always get reflected in the direction of focus. So here this is parallel ray and it should get reflected through focus. But here if you see, the focus is on the left hand side of the mirror, that means behind the mirror. So that's the reason you have to assume that the ray coming from focus like this. So in this way the ray will get reflected. So parallel ray get reflected through focal point. So that's the second one. The second suitable ray is the ray traveling in the direction of focal point. So this is what convex mirror, non-reflecting surface, this is principal axis, this is what you call pole, this is center of curvature, the midpoint is focus or focal point. So what is the ray we are taking here? The ray traveling in the direction of focus. So this is focus. Now we have to take a ray which should go in the direction of focal point. So this is a ray traveling in the direction of focal point. We know that every ray passing in the direction of focal point get reflected parallel to principal axis. So this should get reflected parallel to principal axis in this way. So this is the reflected ray which is parallel to principal axis. This is the second one. Now let's move on to the third one, which is ray passing through the center of curvature. That means ray traveling in the direction of center of curvature. So here I am taking convex mirror, non-reflecting surface. This is what principal axis, this is pole, center of curvature, the midpoint is focal point. So the ray traveling in the direction of center of curvature. So This is what? Center of curvature. So you have to take the ray in the direction of like this. This is the ray. So if you see this, this is in the direction of center of curvature. So here the very important thing is, any line that is passing through the center of curvature is normal to the mirror. So if any ray incident normally, that will be reflected in the same path. That means it goes in the same path. So that means the ray will be reflected in the same path. The reflected ray will also be in the same path. So that means here no deviation found. So the ray will not get deviated. So that's, friends, these are the three suitable rays for convex mirror, which helpful in drawing ray diagram for convex mirror. So let us go for the ray diagrams for convex mirror. So now ray diagrams for convex mirror. So let us discuss about ray diagrams for convex mirror. So as of now we have three rays. We discussed about three rays, three suitable rays. Now we use these three suitable rays to draw ray diagrams for convex mirror. So for this I have taken convex mirror, and I have also taken an object, label it as AB. So we know that to draw ray diagram, at least we need at least two rays. So I am taking first ray. You know that the first ray is parallel ray. This is what? Parallel ray. This is ray 1. So we need another ray. So I am taking a ray which is passing through focus or center of curvature. You may take any one of them. So here I am taking the ray passing through, the ray traveling in the direction of center of curvature. So thus I have taken two rays. This is ray 1 and this is ray 2. So now let us draw the reflected rays for this. So if you see, the ray 1 is parallel to the principal axis. You know that the ray which is parallel to the principal axis will always be reflected through focus. So where is the focus? This is focus. So in this way the first ray will be reflected. So now see the second ray. You know that the second ray passing through center of curvature. You know that any ray that passing through center of curvature will always takes the same path, will be reflected in the same path. So that means this second ray will be reflected in the same path, So thus we got two reflected rays. This is the first reflected ray, this is the second reflected ray. So if you extend these two in the backward direction, so they'll meet at one particular point. So this is at this particular point you will get the image of this object. So here this is first reflected ray and this is second reflected ray. If you extend these two reflected rays, these two reflected rays meet at this point where they will get the image of this particular point. What is this point here? B. The image of B will be formed here. So I am writing B dash. So the image of B will be formed here, which is located as B dash. And now you have to draw a line from this point. You have to draw a line from this point to principal axis. So this is where you will get the image of this A. So this is what? A dash. And this is the image. So you got image here between pole and focus. So in this way we draw ray diagrams for concave mirror. So if you take anywhere in front of convex mirror, you will always get the image between pole and focus. So the image will always be formed between pole and focus. Okay, now see, A dash B dash is the image of this AB. Okay, AB is the object, A dash B dash is the image. So now let us write the characteristics of the image formed by the convex mirror. Characteristics. See here, you will find that, so see, if you see, the size of this object is very small compared to the object. The size of the image is very small compared to the object. So that we can say that the image is diminished image. And what is the second characteristic? If you see this image, the image is above the principal axis. This is principal axis, the image is above the principal axis, so it will be erect image. And the third one is, so here if you see, the image is formed behind the mirror. That means the image formed inside the mirror, in the mirror. So the image which formed in the mirror is called as virtual image. So what kind of image it is? Virtual image. And where is the position? The image is formed between pole and focal point. So these are the four characteristics of the image formed by the convex mirror, and these four characters are similar to any object. If it is placed anywhere in front of the convex mirror, the image will be formed between pole and focus, and it will be diminished image, and it will be erect, and it will be virtual image. The characteristic will also be same for any image formed by the convex mirror. So this is all about ray diagrams for convex mirror. Thanks for watching my video. Please, if you like this video, please like and subscribe to SS Academy. Okay, thank you. Thanks for watching. Bye.